Imagine driving a car from one side of the sea to the other, while hundreds of feet of seawater lie directly above your head. Massive cargo ships are sailing overhead, yet you continue your journey safely through a tunnel deep beneath the ocean. It may sound like something straight out of a science fiction movie, but this is real. Today, some of the world's most incredible underwater tunnels transport millions of people and countless vehicles beneath the sea every year. But how are these gigantic tunnels built under such enormous water pressure? Why doesn't seawater flood inside? And how do engineers manage to construct them deep beneath the ocean? In today's documentary, we'll explore the entire process of building underwater tunnels, step by step. Let's begin. The first step is studying the seabed. Before any tunnel can be built, engineers must carefully examine the ocean floor. Special survey ships are used to measure the depth of the sea, analyze the soil, locate solid rock formations, and identify potential earthquake risks. Advanced technologies such as sonar mapping, deep drilling, and geological analysis help engineers understand exactly what lies beneath the seabed. This is one of the most important stages, because if the ground is unstable, the entire tunnel could be at risk. Once the surveys are complete, engineers decide which construction method is best. Not all underwater tunnels are built the same way. Today, two major construction techniques are used around the world. The first is called the tunnel boring machine, or TBM. The second is known as the immersed tube tunnel method. Let's take a closer look at both. The tunnel boring machine, or TBM, is one of the most advanced engineering machines ever created. It looks like a gigantic circular drilling machine. Some TBMs measure up to 17 meters in diameter and weigh several thousand tons. As the machine slowly moves forward, its powerful rotating cutter head breaks through rock and soil. At the same time, concrete lining segments are automatically installed behind the machine. These concrete rings connect together to form a strong and waterproof tunnel wall. This prevents the surrounding soil from collapsing and keeps seawater from entering the tunnel. The second method is called the immersed tube tunnel. This technique is mainly used where the sea is relatively shallow. Instead of digging the entire tunnel underground, engineers first build massive tunnel sections on land using reinforced concrete and steel. Each section can be hundreds of meters long. These enormous tunnel segments are then sealed, floated across the water, and transported to the construction site. Meanwhile, a trench has already been excavated on the seabed. Using giant cranes, GPS positioning systems, and precise engineering calculations, each tunnel section is carefully lowered into the trench. The individual sections are then connected using specially designed waterproof joints. Finally, the entire tunnel is covered with sand, gravel, and rocks. From the surface, no one can even tell that a huge tunnel lies beneath the seabed. Now comes one of the biggest questions. Why doesn't water leak into the tunnel? The answer lies in modern engineering. Every connection between tunnel sections is protected by heavy-duty rubber seals and waterproof gaskets. The tunnel walls themselves consist of multiple layers of reinforced concrete and steel, designed to withstand enormous water pressure. Inside the tunnel, powerful drainage systems constantly monitor for any moisture. Even if a tiny amount of water manages to enter, automatic pumps remove it immediately. As a result, passengers can travel safely without even noticing the immense ocean above them. But what about fresh air? How can people breathe inside such a long underground tunnel? The answer is a highly advanced ventilation system. Powerful industrial fans continuously circulate fresh air throughout the tunnel. At the same time, polluted air is removed through specially designed ventilation shafts. If a fire ever breaks out, the ventilation system can quickly extract smoke, helping people evacuate safely and allowing emergency crews to respond more effectively. Safety is another top priority. Modern underwater tunnels are equipped with 24-hour CCTV surveillance, fire detection sensors, emergency telephones, fire suppression systems, emergency exits, and sophisticated control rooms that monitor every part of the tunnel around the clock. Many tunnels also include emergency shelters located at regular intervals, providing safe refuge if an emergency occurs. Some of the world's most famous underwater tunnels are remarkable engineering achievements. The Channel Tunnel connects the United Kingdom and France beneath the English Channel. It stretches for nearly 50 kilometers, with about 38 kilometers running directly beneath the sea, making it one of the longest underwater tunnels ever built. Another extraordinary example is the Tokyo Bay Aqua Line in Japan. This unique transportation system combines both a bridge and an underwater tunnel, creating one of the most innovative road projects in the world. Many other countries continue to build new underwater tunnels, connecting islands, cities, and entire regions that were once separated by vast stretches of water. But projects like these come with an enormous price tag. Building an underwater tunnel can take many years to complete. It requires thousands of engineers, construction workers, giant machines, and some of the world's most advanced technologies. As a result, the total cost of a single project can easily reach several $billion. However, once completed, these tunnels save millions of hours of travel time, reduce fuel consumption, improve transportation, and boost economic growth for decades. In the end, underwater tunnels stand as one of humanity's greatest engineering achievements. There was a time when crossing the sea meant relying entirely on ships and ferries. Today, thanks to modern engineering, trains, cars, and millions of people travel safely beneath the ocean every single day. And as technology continues to advance, the future may bring even longer, deeper, and more extraordinary underwater tunnels, connecting distant parts of our world faster than ever before. What do you think? Could Bangladesh one day build its own underwater tunnel beneath the sea? Share your thoughts in the comments below. If you enjoyed this documentary, don't forget to leave a like, share it with your friends, and subscribe to our channel for more fascinating videos about science, engineering, and incredible technology. Thanks for watching. See you in the next video.